property. How does metallic property change in a period and in a group? On the left we have the metals, on the right we have carbon, fluorine, neon, all are non-metals. Chlorine, argon, non-metal. Bromine, krypton, non-metal. Potassium, calcium, metals. So metallic property will decrease in a period. Why does metallic property decrease? This is once again, what is a metal? Metal is something that will lose electrons. A metal will lose electrons, which means after losing electron, metallic atom will get a positive charge. So metals are electropositive. Right? Now, as we go from left to right, what happens? The pull of the nucleus on the outermost shell is more stronger, which means that it will be difficult for an element to lose the electron. On the other hand, what will happen? Being non-metals, they will gain the electrons. That is why metallic property will decrease in a period, because ability to lose electrons will decrease. Electropositive nature will decrease. What about in a group? As we come down the group, will the metallic character increase or will the metallic nature decrease? In a group, metallic nature will increase. Why? Take for example, let us say lithium, sodium, potassium. Lithium has, being in second period, has two shells, let us say K and L. Sodium will have three shells and potassium will have four shells. So in this case, what happens? The distance of the outermost shell from the nucleus is increasing, atomic size is increasing. Because the distance is increasing, the effective nuclear charge will decrease. The control, the pull of the nucleus on outermost electron will decrease. When electron is not attracted to it, it is very easy for the electron to be lost. So on one hand, the number of shells are getting added, atomic size is increasing. Because of that, effective nuclear charge will decrease, because of which electrons can be easily lost. So metallic property will increase in a group. In between fluorine, chlorine, bromine, right? If you compare this group, these are all non-metals. But when compared to fluorine, the non-metallic property of chlorine will be less. When compared to chlorine, bromine will be less non-metallic, because as we go down the group, ability to lose electrons will increase, which means in this case ability to accept electrons will decrease. So go down. If you look at the original periodic table, on the non-metallic side also, you can see in period number 6 and 7, you will find metals. In spite of them being on the right side of the periodic table, the last property, that is electronegativity, in simple terms it is nothing but non-metallic property. This will be your electropositivity. What is electronegativity? When does an atom become negative? When it gains an electron. So whenever an atom accepts or gains an electron, it will have more electrons and less protons, because it has taken extra electron. So it will become negatively charged. It will become an anion. Right? So how do we define electronegativity? In simple terms, electronegativity is nothing but the ability of an atom to gain electrons. Now, which kind of elements will gain electrons? It is very obvious, it is the non-metals, because metals will lose electrons, electropositive. Non-metals will gain electrons, electronegative. So, let us see how does this trend occur in a period and in a group. In a group, it is very clear. As we go down the group, metallic character will increase, which means electropositivity is increasing, meaning electronegativity will decrease. In a period, how does electronegativity change across a period? Electronegativity will increase. For a change, third period, we have sodium. Sodium atomic number is 11, so 2,8,1. In the same period, we have magnesium, atomic number 12, 2,8,2. Right? So, looking at the balances, we know that sodium can lose one electron. So, sodium valence is 1. It can lose one electron. After losing one electron, sodium will get a positive charge. Now, we also know that as we go from left to right, effective nuclear charge will increase. The pull of the nucleus on the electron will increase. So, in the case of magnesium, it will be very difficult to lose 2 electrons. Because for removing an electron from the valence shell, it requires energy. This energy is called as the ionization energy. Ionization energy is required. Energy required to make ion. Now, if you want to remove one electron from the outermost shell, you need to supply energy. Only then it will become ion. Ionization energy. As you remove one electron from the outermost shell, what will happen? Decrease. For example, let us say magnesium. Magnesium nucleus is present, and these are the shells. So, in the outermost shell, there are 2 electrons, and magnesium, to become an ion, Mg2 plus, needs to lose 2 electrons. So, let us say by supplying ionization energy, by giving energy, you have removed one electron. You have removed one electron. So, when you remove one electron, what happens? There are now 12 protons and 11 electrons. So, the nuclear charge will further increase. The control of the nucleus on this electron will increase. It will strongly attract it. Now, the second ionization energy 2, energy required to remove second electron. This electron will be much higher. Lot of energy is required to remove this electron. So, it is very clear, as we go from left to right, because effective nuclear charge is increasing, the ionization energies will increase. Atoms will not lose electrons willingly. In fact, they will gain electrons. So, electronegativity will increase in a period. We have completed periodic classification of elements. Thank you.